Hey everyone, welcome back to the Learning Addict. Last time we installed Go and VS Code and ran our very first Hello World application just to make sure everything worked. Today we're leveling up. We'll dissect that tiny program line by line so you truly understand what's happening, see how Go builds and runs code, and most importantly, move from a single random file on your desktop to a clean professional project structure using modules and packages. This is the exact foundation the Go community recommends in 2026 for any real project you'll actually keep or grow. So let's dive in. All right, so let's break it down slowly. Here we have package main. So every Go source file must start with a package declaration. Package main is special. It tells Go, this is an executable program, not a library. The main package is where your program starts. Only package main can have a main function that runs automatically. Import brings in other packages. fmt package, as you can see on line 4, is short for format and handles printing, scanning, string formatting, and much more. Super common to use for beginners. Function main is the entry point. Go automatically calls this when you run the program. Everything your app does lives inside of these curly braces. Here in line 8, we call print line from the format package. We pass it a string, text in double quotes, as you can see here. It prints the text followed by a new line, and that's it. 9 lines, but they teach you the entire skeleton of a Go program. So here I have hello world.go saved on my desktop, and you can verify this. We can verify this by typing ls and seeing that on my desktop, hello world.go. And we can run a quick test. We can run this code without having to build by typing in go run hello world.go and hit enter. There you see hello world. So go run is awesome for fast iteration. It compiles in memory and executes instantly. So it's great for experimenting or testing your code at certain checkpoints. Now that we know how to use go run, now let's build a real executable. And we do that by typing in go build hello world.go. Watch, it will create a hello world binary. We type in ls again. And here you see this hello world executable. And if I move my application over to the side so you guys can see my desktop, here you can see this hello world executable. So once an executable is made, we no longer need any Go on our computer. You can literally copy that, move it over to your friend's Mac computer, and it should run by typing in ./hello world.go. And there you see hello world. That's pretty neat, right? But here's the catch. If this grows even a little, adding features, tests, dependencies, working with loose files like this gets messy real fast. Go's modern way is modules. So here I've already created a dedicated project folder for us ahead of time to save a bit of typing. At the top level, we have main.go, and inside the greeter directory, we have greeter.go. The idea here is that main.go will import and use the code from our greeter package. Let's start by looking at main.go, which is right here in front of us. So notice that we're trying to import our own local package here. That's the greeter directory you see in the project tree. Now let's take a look at the code inside that package. All right, at the very top of this file, we have the package declaration. Every Go file needs one of these, like I mentioned before. It tells the Go compiler which package this file belongs to. In this case, the file belongs to a package called greeter. In Go, it's very common for the package name to match the directory name. Since the file lives inside the greeter folder, we name that package greeter as well. That keeps things predictable and easy to navigate when projects get larger. We know exactly what the import section does, so I'll skip that. And moving along here, below that we have the function called greet. This function here, this function is very simple. It just prints hello world to the console, just like in our single file application. But one thing to notice here, the function name starts with a capital G. In Go, capitalization controls visibility. When a function starts with an uppercase letter, it becomes exported, which means other packages are allowed to call it. If our function started with a lowercase g, then only code inside the greeter package could use it. Main.go wouldn't be able to call it at all. So by naming the function greet with a capital letter G, we're explicitly making it available to anything that imports this package. Now let's jump back into main.go and see how this actually gets used. All right, so here I have main.go pulled back up. So everything looks fine here. The package is imported and we're calling greeter.greet. At first glance, this looks like it should work. VS Code isn't showing any errors and the code itself looks perfectly valid. But watch what happens if we actually try to run the program. Let's type in down here in the terminal, go run. I'm just going to use a period shortcut and hit enter. And you see that? Go immediately complains. The reason is that we haven't initialized a module yet. There's no go.mod file in this project. Without a module, Go has no idea how to resolve imports, even local ones. It doesn't know what the root of the project is, and it doesn't know how packages inside the project relate to each other. So even though greeter folder is right there in the project, Go still refuses to build the program. All right, let's fix this by initializing a Go module. And we do that by running go.mod init, and then followed by a name, which I'm going to type in hello app. So for local or learning projects, simple names like hello-app are perfectly fine. But if you plan to put this on GitHub or share it with others, it's better to use a full repository path right from the start. So for example, I would type in rather github.com, whatever, username / hello app. So this way, once it's pushed to GitHub, anyone can import your module seamlessly. And as a heads up, changing this module path later can be painful, so it's best to decide upfront. But since we don't plan to share this awesome package, I will set it back to hello app and hit enter. And boom, see that? Go created a go.mod file in the root of our project, which is right here. So let's unpack exactly what this does. First line, line 1, module hello app. This is your module path, basically the unique permanent name for your project. Think of this as your project's forever ID. Every import inside your project starts with this prefix. For example, our local greeter package is now importable as following. I can go back here to main.go and let's fix this. Instead of dot, we would type in hello app, because that's the root of our, and you see how the squiggly lines went away. So let's go back to go.mod. Without this line, Go has no root to resolve import paths from. That's exactly why earlier Go run failed. All right, let's move on to the next line, line 3, which is go.1.24.6. This declares the minimum Go version your module supports. With these two lines in place, Go knows where your package lives and what version rules to follow. So now that we have go.mod, let's try building again. Let's type in, down here in the terminal, let's type in go run space period and hit enter. And yes, the error is gone. The module path gave Go the context to find and use our local greeter package. All right, next let's run and build the module. So let's type in go build and hit enter. And you see that here it created the binary hello app. All right, so let's go back to the terminal and let's run it. And we do that by doing a /hello app and hit enter. And you see that same output, but now fully modular, testable, and scalable. All right, bonus tip. So for larger projects, you can move packages into an internal folder to prevent external paths. So for example, if I create a folder here, name it internal, I move everything. I move the greeter directory inside internal. So there. Now our hello app doesn't know where our greeter app is because it's now inside the internal directory. And then now you see our project tree. It's internal, then greeter. And what this does is Go will prevent outside code from importing anything inside internal, which is great for maintaining clean boundaries. All right, and that's your first real Go program, written, run, built, and properly structured with modules and packages. You've seen firsthand why go.mod init is a non-negotiable for local packages. No module means no local imports. You've just avoided the #1 beginner trap, files without modules. If this helped, please hit the like button and subscribe to support the channel. Thanks for watching.